In this video, we are going to talk about using scale factors in similar polygons to find areas. So if you remember when we're doing scale factor, so scale factor in any two similar polygons is just the ratio of any two corresponding side measures. So if you have the height in two shapes or the base length in two shapes, any corresponding side length measure. And so we write that out as A dot B as a ratio. And then ratios, remember, can be written as fractions, which will come into play later. And then the ratio of the perimeters is actually identical to the scale factor. Okay, so this is also an A to B ratio. So if you were to calculate the perimeter of two similar shapes, simplify their ratio or their fraction, it would be exactly the same as the scale factor. And then for area, area is actually A squared to B squared. Okay, and I usually remember this because measurements, so length measurements, perimeters, those are measured in units like centimeters, feet, yards, stuff like that. And then area is measured in square units. So like centimeters squared, feet squared, yards squared. So length measurements are the A to B ratio for scale factor perimeter. Area ratios are A squared to B squared. So if we had, let's say we had 2/3 or 2 to 3, so then the perimeter ratio would be 2 to 3 as well. And then the area ratio would be 2 squared to 3 squared, which is 4 to 9. So if you square it out. So let's fill in this table here. So we've got 3 different columns, side length column, which is the scale factor. Okay, so ratio of the corresponding side lengths. This is also known as scale factor. And then you've got ratio of perimeters and you've got ratio of areas. So remember, the scale factor is A to B ratio. Ratio of perimeters is also A to B. And then ratio of areas is A squared to B squared. So we've got the A-B ratio. 6 is A, B is 13. So then this one is going to be the exact same thing. So the ratio of the perimeters would be the same as the scale factor. And then this one is going to be 6 squared and 13 squared for the areas, which multiplied out is 36 to 169. Okay, so the ratio of the areas of those two shapes doesn't even matter if you know what the shape is. We don't even have a shape shown here. We just know that we've got similar side lengths, similar figures. So then now this one, okay, the second row is giving us the A squared, B squared. Okay, so A squared is 25, B squared is 49. So if A squared is 25, then we would square root to figure out A. So A is 5. And then similarly with the 49, so B squared is 49, so just square root, and you'll get that B is 7, which then is also the perimeter ratio, 5 to 7. And in this final one, we're given the perimeter ratio, so that's 2 to 3. Okay, so then our scale factor ratio is 2 to 3, and our area ratio would be 2 squared to 3 squared, which is 4 to 9. Then let's actually take a look at doing this in a couple shapes. So we've got similar polygons here. Okay, we've got the similarity statement. So I would use that similarity statement to figure out which sides are corresponding, to figure out your scale factor. So I like to put dots on the shapes, okay, to show which sides are corresponding. So side AB, so this one, so AB goes with EF. Okay, and then those are actually, we've got both of them filled in, so I could stop at this point, but I'm going to look at this FG as well. So FG and BC are also corresponding. So now when you go to do the scale factor, you compare any two corresponding sides. So they need to both have numbers next to them. So we can't use this BC compared to FG just because we don't actually know how big BC is. So triangle ABC is the red triangle and triangle EFG is the blue triangle. So that's the ratio that we're doing here. So we're comparing the red shape to the blue shape. So from this red shape, we get a 16, okay? And the corresponding side to that in the blue shape is 10. So 16 to 10. And then we would want to simplify out any common factors. So both of these divide by 2. So you would simplify that. And get 8 to 5 for the ratio of the scale factor of the red shape to the blue shape. And then because we're going to answer some more things, I'm just going to write these in the middle of the shape. I just like to write them in the middle of the shape just to remind me that that's the scale factor, because we can reuse the simplified version. You don't have to keep using the 16 to 12. So for this next one, we want the scale factor of EFG, so the blue shape or the blue triangle, to ABC, the red one. Okay, so now we'll take the measure out of the blue and compare it to the red. Again, I'm just going to take the 5 to 8 because it's already simplified. You could do 12 to 16 and simplify again if you want to. Then the area ratio. So now we're doing ABC to EFG. Okay, so we're starting in the red shape. And so this 8 is like your A, right? So we're going to be doing 8 squared compared to 5 squared. So taking that simplified scale factor and squaring it out. Making sure you took from the red shape, the first one they talked about, to the blue one. So 8 squared is 64 and 5 squared is 25. And then ratio of the perimeters. So remember, perimeters is an A to B ratio. Okay, just like the scale factor. So this was A to B for scale factors. And then ratio of areas was A squared to B squared. So we just want the scale factor again for this one. So blue to red in this case. Okay, so we're doing blue first and then red. So the blue number is the 5 and then the red number is the 8. Then let's actually solve for some missing information here. So we need scale factor. So remember, scale factor just compares the corresponding side lengths. Okay, so determine the ratio, and it says to do red to blue. So we're going to do the red number first compared to a similar side length in the next one, so 2 to 8. And then we would simplify this. Both divide by 2, so these would simplify to a 1 to 4 scale factor. Ratio of perimeters then is also 1 to 4. Ratio of areas, so areas is A squared to B squared. So this is going to be 1 squared to 4 squared, which is 1 to 16. Now we need to actually find the area of the blue shape. Okay, and so this is going to be using proportions. Okay, so for similar figures, so we want the area of the blue. Okay, so area of the blue compared to area of the red should be equal to your area ratio. So the A squared to B squared. So when you're comparing areas, like you remember comparing side lengths, we would set up a proportion and set it equal to the scale factor. So now we're doing area to the area ratio. Okay, so area of blue, area of red, A squared to B squared. Okay, so the area of the blue shape is what we're looking for. The area of the red shape we know. Okay, they gave us the area of the red shape is 6. Okay, and then equals, so again, we're looking for the blue shape, so I'm going to make this blue. So now we want this number to come from the blue shape. So remember how I said I like to write the numbers in the shapes? You could still do that. So this 1 came from the red, and the 16 came from the blue. So then this is going to be 16 coming from the blue, and then the 1 came from the red, and then we could cross multiply. So this is just going to end up multiplying. X times 1 is just going to be X. 6 times 16 is 96. And then this one is feet, and we're doing area, so feet squared. Okay, let's try one more. So this one, again, let's do the scale factor, and they want the red to blue scale factor. So we'll be comparing 15 to 20. Both are divisible by 5. So we'll divide by 5 to get 3, divide by 5 to get 4. Okay, so your A is 3, your B is 4, if we want to do it that way. So then when we look at our scale factor here is 3 to 4. Our ratio of our perimeters is 3 to 4. So our ratio of our areas is going to be 3 squared to 4 squared. So this is going to be 9 to 16, which then we're looking for an area. Okay, so I'm going to write down the A squared ratio here was 9, and the B squared was 16. And then we're going to set up a proportion again. Okay, so again, this will be, and you can switch, you could put area of red on top, blue on bottom, whatever you want to do. So maybe I'll just do the red on top this time since we switched it last time. So the area of the red, okay, compared to the area of the blue should equal your A squared to your B squared. Okay, your number from your red shape to your blue shape for the scale factor. Okay, so area of the red, we don't know this time. Okay, so this should actually say red right here. So area of the red, we don't know. So I'm going to call that X. And then area of the blue we have is 240. And then this should be A squared to B squared. So using these A squared and B squared numbers. So 9 to 16. Then you can cross multiply here. So you'll have the 16 times X, and then 240 times 9 is 2,160. Then you can divide by 16 to both sides and get that X equals 135. And then the units are inches, so inches squared.